Today we're going to start with activity 2.8 in the CASEL curriculum, which is called Comparing the Resistance of a Wire with a Bulb Filament. So I'm going to start here with just setting up a basic circuit with one light bulb and our compass. And as you can see, I've got the compass and the wire over it taped down so that the needle of the compass, which of course is pointing north, is aligned under the wire. Now the reason I tape everything down is so that we can get a reproducible result when we connect the circuit and get a consistent deflection of the needle that we can measure. So I can actually count how many little lines over the needle moves or deflects when I do this. That way my wire is not shifting around the position of my compass, and I can really get a good comparison. But this is the basic setup that you've seen before. When I close the circuit, the light bulb lights up. You can see the needle, compass needle deflects about 2 of those gradations, of those black lines around the compass in this case. So number 1 under 2.8, under exercise 2.8 says start with a circuit containing a round bulb and 2 D cells. Okay, that's what I have here. But it says open the circuit and add a long coil of wire provided by the teacher. But before adding the wire, make a prediction. So what I'm going to do is I'm going to take this long coil of wire right here, and this wire is coated with a thin layer of paint that insulates it. And I've scraped that paint off the ends with some sandpaper so that I can make a connection here. But what I'm going to do, and notice I've got the circuit open at this point, I'm going to add this long piece of wire into the circuit. So now the charge is going to have to go all the way around. It's going to have to go through all of this wire to get to the other side. But it says before adding the wire, so before completing the circuit, I am going to make a prediction. Predict the effect on compass needle deflection. So is the compass needle going to deflect more or less, or in the same direction or different direction? And second, predict the effect on the round bulb brightness. Is the bulb going to be brighter, dimmer, or maybe the same? Or maybe it won't work at all. So predict the effect on these 2 things. Before you hook it up, make your prediction. And then, number 2, we're going to connect the long coil of wire and describe the effect on needle deflection and bulb brightness. So we're going to hook it up, we're going to describe the effect. So what actually happens, so basically this prediction is a hypothesis. Then we're going to describe the results. How much did the needle actually deflect and in what direction? How much did the light bulb actually light compared with the previous circuit? And then finally, what can you conclude about the resistance of wire from this activity? So is the resistance of wire, say this wire right here, greater than, less than, or equal to the resistance of the light bulb? So go ahead and set this up, connect it, answer the questions, and you're done with section 2.8.